all of you? What we are going to study is mechanism and what we mean by mechanism, and we will just study about what we mean by inversions of mechanism. So this is the thing what we are going to discuss. So the subject I am handling is theory of machines. In that, we are going to study what we mean by mechanism. Okay, why there is a mechanism, what is the specialty of a mechanism, etc. We will discuss in this chapter. Okay, so we are starting with mechanism. So I am audible. Somebody's mic is on. Okay, please mute. Okay, so today the session what we are handling is theory of machine. So I think I'm audible now. My sound is clear now. So the subject theory of machine may be defined as the branch of engineering science which deals with the study of relative motion between the various parts of the machine and the forces which act on them. That's the specialty. The theory of machine may be defined as the branch of engineering science which deals with the study of relative motions between the various parts of the machine and forces which act on them. The knowledge of this subject is very essential for an engineer in designing the various parts of a machine. So how if you are connected with two links, for example, if two links are there, okay, just wait. I will share a just wait. I will share a PDF so that I can explain it also. So actually, this theory of machine relating to various machines in which there will be different links. Each part of the machine will be known as links. These links will be connected each other. Then only there will be motion between the links. That is what we discussed. Okay, sorry for the delay. It's heavy rain over here, so lost my connection. Sorry for that. Okay, so I am audible now.
Yes, yes, yes.
So you can see my screen now. So next thing what we are going to study is kinematics and kinetics. So kinematics is nothing but the study of motion with regard to forces. When we are discussing in regard to forces, okay, that comes under what kinematics. Kinematics is with regard to forces. So when we study the study of forces on the system in motion, okay, that comes under kinetics. Okay, kinematics is study of motion without the regard of forces. But when you study the forces, kinetics, and kinematics is study of motion without considering the forces. The two concepts, that means one is to design a desired motion. Okay. So next is used to compute the mathematical velocities, acceleration, positions, etc. So that is the difference between kinematics and kinetics. So kinematics is the study of motion without the regard of forces, but kinetic means study of forces on the system of motion. Okay. These concepts are really not. Can you move, please? So our principal aim of kinematics is to create a design, the desired motion of a subject mechanical parts. Okay, if you want to create design of the mechanical parts, we will be using kinematics. And when you have to mathematically computer for the position, velocity, and acceleration, we use kinetics. Okay, now we will move on to next PPT. Then machines and mechanism. A mechanism is a device which transforms the motion of some desirable pattern and typically develops very low forces and transmits little power. A mechanism. So, so a mechanism is a device. You can say mechanism is a device which transforms the motion of some desirable pattern and typically develop very low forces and transmit little power. But when it becomes a machine, what happens? It will transmit significant power. That's the specialty of the difference between mechanism and a machine. Okay. So mechanism is, if you say a 4-bar thing, if it's a fixed, there is a link over here like this. So if this link rotates, this will also move. Okay. So this is a mechanism. But when we develop this into a machine, it becomes a machine which will transmit force as well as significant power. Okay, now. So that is the difference between mechanism and machine. Okay, we will study in detail, don't worry, these things. So I have told you, if there is a link over here, there is a link. Okay, so this will rotate. When this rotates, what happens? This link will move and this will also move together. Okay, so this is a mechanism. Okay, so but if they, on the other hand, a machine is a system of elements arranged to transmit motion and energy in a predetermined fashion. For example, engine is a machine. Okay, what is the function of engine? To transmit power. Okay, it's a 2-stroke engine. It's used to run the scooter. Okay, 4-stroke means it is used in bikes as well as cars, etc. Okay, depending upon the use. Okay, so that is a machine. Okay, machine. So it has got some definite work or definite motion and energy. Okay, but when it comes to mechanism, it will be arranged to transmit only motion. Okay. So this is a example for a mechanism. Move package from assembly bench conveyor to, so if you keep it here, if you want to move something over, you will place it here and it will move according to, this is a moving package from assembly bench to conveyor. Okay, this function is to move. When it is full, it will move to here. Okay, its function is to move packages from assembly bench to conveyor. So this is a mechanism. The function is that it is just moving to the left side. Okay. Next is, we have got a criteria known as pushback criteria. Okay, so this is a very important criteria. So here the equation is F is equal to 3 into L minus 1 minus 2J minus H. Okay, this is an important criteria. Here L represents the number of links. Okay, J represents the number of. Okay, so if we are having a mechanism like this, so this mechanism is named as A, B, C. These are known as bars or links. Okay, no. So how many links are there? 1, 2, 3. Okay, no. So these points are known as joints. Okay, no. Okay, clear. So when you apply over here, 3 into, how many links are there? 3 minus 1. How many joints are there? 2 into 3. If there higher pair means if you have any point contact, there is a point contact like this. If for example a cam is connecting at a point, so this comes under point contact. If any point contact is there, it comes under higher pair. So there is no higher pair, it becomes 0. So what is this? 3 into 2 minus 2 into 3. What is this 0? What is F? F is the degree of freedom. Okay, degree of, okay, no, degree of freedom. So what does that mean? This degree of freedom F is 0. That means the degree of freedom is 0. Degree of freedom 0 means what is that? All of you should understand that that is a structure. Okay, is it clear? Structure. What are structures? Railway bridge is a structure. All the bridges are structures. Our house is a structure. So what is the specialty of these structures? They will be having degree of freedom 0. Okay, when the degree of freedom is 0, it becomes a structure. I think the concept is clear now. When the degree of freedom of a system is equal to 0, it forms a structure. Okay, now shall I proceed further? No. Now, if it is a 4-bar mechanism, for example, so this is 4. 1, 2, 3, 4. This is a 4-bar mechanism. Okay. So what is our equation? F is equal to 3 into L minus 1 minus 2J minus H. Okay. Okay, no. So if it is 4-bar means how many links are there? 1, 2, 3, 4. How many joints are there? 1, 2, 3, 4. So number of links is equal to 4. Number of joints is equal to 4. Okay, no. So 3 into L is 4 minus 1 minus 2 into how many joints? 4. There is no higher pair, so it is 0. So what happens? 3 into 3 minus 2 into 4. So what is 9 minus 8? So it becomes what? 1. So the simplest form of mechanism is a 4-bar mechanism because it is having degree of freedom 1. Okay. So a system to be a mechanism, it should have 4 bars. Okay. Then only a system will be in can be said to be a mechanism. Okay. So how this mechanism becomes? So I think its concept is clear, no? The simplest form of mechanism is a 4-bar mechanism, and if for a system to be a mechanism, it should have 4 bars. Okay, now? Any doubt? This is how you will be calculating. We know that there are 4 links over here. Joints are 4. When we apply the equation, we will get the degree of freedom as 1. So it means that there is a degree of freedom 1 for the system. So it is having some degree of freedom. It is having some movement to any of the sides. So there is a degree of freedom. So from this, you will understand that it is a mechanism. So the minimum criteria for a mechanism is a 4 bar. Okay, is it clear? Then I will proceed further. So next topic what we are going to study is inversions of mechanism. Inversion of mechanism. Before going to that, what do we mean by absolute motion? Okay, so if you are having a frame like this is A and this is, when you are measuring motion with respect to this fixed frame, it is known as absolute motion. Okay. But if there is another link over here, we can name it as C. If when you are considering B and C, it will be having relative motion. Okay, no? Is it clear? Any doubt? I think it's clear. When your absolute motion is measured with respect to a stationary frame, you have to understand when we are measuring with relate to a stationary frame, it forms what kind of motion? Absolute motion. Okay, no? Okay, clear now? Okay. So relative motion means when you are considering B and C, B will be moving relative to C. So they comes under relative motion. So this is the another criteria. Then most important thing what we have to study over here is what we mean by mechanism. I have told you there are so many mechanisms, 3-bar mechanism, 4-bar mechanism, but I have told you 3-bar is not a mechanism, it means comes a structure. So the simplest mechanism is a 4-bar mechanism. So let me draw a 4-bar mechanism over here. You may see this is one. This is, okay, I am drawing this before that. I'll wrap this one. We'll draw it once again. So this is the mechanism. You may, this is the mechanism I have to. This is link 1 is link 4. Okay, no? So a 4-bar system to be a mechanism, any link, one of the links have to be fixed. So we are fixing this link. So when link 1 gets fixed, it forms a mechanism. Okay, no? When link 1 gets fixed, it forms a mechanism. And if you are changing the fixed links one by one, it forms inversions of mechanism. I think it's clear. So when one of the link get fixed, it forms a mechanism. And when we change the fixed link, you will get inversions of mechanism. So when one of the link is fixed, it is in a kinematic chain. It is known as mechanism. So this system is known as kinematic chain. So these are known as links. Links. This is link. This is link. This link. When different links are connected in such a way that there is a definite motion, it forms a kinematic chain. Okay. When one of the links of a kinematic chain gets fixed, it forms a mechanism. I think. Okay. So when if you are having a 4-bar chain, kinematic chain, when one of the link of a 4-bar gets fixed, it forms a mechanism. Okay, what is a way that there is a definite motion, it forms a kinematic chain, and when one of the links of a kinematic chain gets fixed, it forms a mechanism. Concept is clear now? I think the concept is clear. We will move onwards. So we can obtain as many mechanisms as the number of links in a kinematic change by fixing in turn different links in kinematic change. And when we change the fixed link, we will get inversions of mechanism. This method of obtaining different mechanism by fixing different links in a kinematic chain is known as inversions of mechanism. Okay, this is known as inversions of mechanism. Okay, so we obtain as many mechanisms as the number of links in a kinematic chain by fixing in turn different links in a kinematic chain. What is the only concept is that if we are having a 4 bar 1, 2, 3, 4, actually first was fixed. Now if you are changing it to 2, we will get one mechanism. When you change to 3, we will get another mechanism. When you change it to 4, you will get another mechanism. The changing of this fixed link is known. When you change this fixed link, you will get what? Inversion of mechanism. When you change this fixed link, you will get inversion of mechanism. Okay, now? So, the most important kinematic chain are those which consist of 4 Lowell pairs. I have told you. Each pair is being sliding pair or turning pair. So what is sliding pair, what is turning pair, I will explain. So actually we have to study 3 types of mechanism or chain. That is 4 bar mechanism, slider crank mechanism, and double slider crank mechanism. So when we study this mechanism, you might so many places. Okay, or the place you are working, or when you are going through the road, you may find these type of mechanisms. Okay, so first thing what we are going to study is 4 bar mechanism. So actually you may see this is a 4 bar mechanism. So this is the 4 bar mechanism. Okay, so it consists of 4 links. Okay, so the links are A, B, C, D. Okay, you may see over here this you may see here. So this is A, B, C, D. When this AD rotates, AD is known as the crank. Okay, crank will rotate. It is the smallest link. Smallest link is crank. Okay, so the crank will rotate. When the crank rotates, what happens? This DC is known as connecting rod. Connecting rod. Okay, so this will slide and it will move BC. BC is known as follower. Okay, so this is crank. This one is fixed link. This is known as fixed link. Next is smallest link, which is known as crank. Then connecting rod and follower. Okay, so connecting rod will transmit motion from crank to the follower. Okay, now it's clear now. So when you change this fixed link, you will get different inversions of mechanism. So you may see link AD, that is link 4 is known as the crank. Link BC is known as the lever, rocker or follower. And when the link CD, which connects the crank and lever, is known as the connecting rod or coupler. Fixed link 1 is known as the frame of the mechanism. Okay, so what is this specialty of this mechanism? So this rotary motion AD will be rotating. You may see rotary motion of AD is converted to translatory motion. Okay, no, because this will trace a circle, but this BC is having very large radius when compared to AD, so it will not trace a circle, it will just oscillate. Okay, no? Okay, no? Concept is clear, no?
Okay. Yes, yes.
So this So the specialty is known as specialty of this mechanism is known as specialty of this mechanism is that when you design a crank, the crank should make full rotation. Okay, otherwise we cannot use this mechanism. Okay. So next is Kirchhoff's law. Kirchhoff's law states that for a planar four-bar chain mechanism, the sum of shortest and longest link, the shortest link is crank, and whatever be the longest link, cannot be greater than the sum of the other two links. Okay. So this is what Kirchhoff's law. So it explains that sum of the shortest and longest links cannot be greater than the sum of the other two links if there should be continuous relative motion between the two members. So next what we are going to study is inversions of four-bar mechanism. So how will you get inversions? You may see we are changing the fixed link over here. You will get different inversions. So how you will get this one is I will explain. I will show you with one of with the important mechanism are beam engine, coupling rod of locomotive, and Watt's indicator mechanism. This beam engine is known as rocker mechanism, crank and lever rocker mechanism. Coupling rod of locomotive is known as double crank mechanism, and Watt's indicator mechanism is double lever rocker mechanism. So how I will explain how you can see over here. So when you after the class, so you can this link is over there. YouTube link is of the mechanism is over there. You can just watch it. Okay. So otherwise we will lose the time if in between I am going to show you. So here rocker beam engine or rocker crank and lever mechanism is the thing is that here frame link one and the cylinder portion will get fixed. Okay. So you can see here this portion is fixed and cylinder portion is also fixed. Okay, now the figure also you can see. Okay, this is fixed over here. When this AB is the crank. Okay, now so when this AB rotates, what happens? Link 3 will oscillate. Okay, so when it moves up, this C will be moving up. At that time, E will move down. So a piston will be there in the cylinder. It will be moving up and down depending upon the rotation of this crank. I think it's clear now. When the crank rotates, then link 3 connected to this crank will move up and down depending upon the rotation of the crank. So this is transmitted to lever by lever 4 to this piston rod. So the piston rod inside the cylinder will move up and down or it will oscillate. Okay, no? Okay, no? So this type is known as beam engine or crank and lever rocker mechanism, or you can say it as beam engine. So in this mechanism, you may see the crank rotates about a fixed center A, the lever oscillates about the fixed center D. So lever will be oscillating about there is a fixed center D over here. The lever will be D over here. The lever will be rotating with respect to D. Okay. The end E of the lever CD is connected to a piston rod which reciprocates. I have told you it will be reciprocating inside the cylinder due to rotation of the crank. In the other hand, the purpose of mechanism is convert what is the here what was the rotary motion into what you are getting final output reciprocating motion. Here rotary motion is the which is converted here into reciprocating motion. Okay, no? Whatever rotary motion is here, it is converted into reciprocating motion. I think it's clear. Next, we will go with coupling rod of locomotive. This you might have seen. It is the technique what we use in railway. Okay, coupling rod of locomotive. That means there is a wheel over here. So here link 1 gets fixed, AB gets fixed. Okay, Here there is a crank AT, and here also there is a crank BC, and this okay. So I will once again explain this one. So coupling rod of a locomotive. So this is known as double crank mechanism because here the link AD and BC will act as what? Cranks. Okay. So this AB will be fixed link and CD is another link or the connecting rod. What you say it is connecting rod. So the specialty is that when this AD is rotating, okay, this AD is rotating, the connecting rod corresponding to the AD will move BC together with this. Okay. So when you see a train, what is the specialty? There will be the wheels will be moving together. Okay, now. So when this is rotating, it will take this also together with this. You might have seen in old steam engines, videos, etc. So this is known as coupling rod of a locomotive. So I think the concept is clear now. In this mechanism, AD and BC have equal length, acts as the cranks and are connected to the respective wheels. Link CD acts as the coupling rod and link AB as the fixed link in order to maintain constant center distance between them. The mechanism is used for transmitting rotary motion of one wheel to another wheel. So whatever rotary motion is happening here, it is transmitted to another wheel. So rotary motion is transmitted to another wheel. Okay, no. So the motion is rotary motion to rotary motion. Okay, no. Next is Watt's indicator mechanism. So Watt's indicator mechanism specialty is that so it consists of 4 links. Link A is fixed. Similarly, the indicator cylinder is also fixed. Okay. In that cylinder, there is a indicator plunger. Was there? Plunger is there. For example, if you are having any machine for reading, there is a reading device over. Okay. So what do you say? Indicator plunger. Okay. So here you have to see that B, F, and FD are of same are on one link because these two parts have no relative motion. So they will not be having a relative motion. Okay. So what happens when there is a pressure from the cylinder? You may see this mechanism. When there is a pressure from this mechanism cylinder, what happens? This will move up. So whatever point E over here, it will be tracing to E dash. Similarly, the points B will become B dash, C will become C dash, D will become D dash. Okay, no? Okay, clear, no? So it will trace in another path. Okay. For example, if you are having an indicator over here, when some pressure is applied, this indicator will change to this. Okay, that is the thing. Okay, so when a pressure is applied, this indicator position will be changed. Okay, so this comes under Watt's indicator mechanism. Okay, so this full line represents the initial position of the mechanism, and when we apply pressure, you will get what this dotted line will represent the position of mechanism when the steam pressure or the gas pressure acts on the plant. Okay, no? So I think it's clear what's indicator mechanism. Next is single slider crank mechanism. So this single slider crank mechanism, single slider means there will be a slider. Slider means you may see this piston cylinder mechanism. This will be sliding. This piston will be sliding inside the cylinder. Okay. So a single slider crank chain is a modification of a basic 4-bar chain. It consists of one sliding pair and 3 turning pairs. So it will be having one sliding pair and also 3 turning pairs. It is usually found in reciprocating steam engine mechanisms. So these are found in reciprocating mechanisms. So here what is the function? It converts rotary motion into reciprocating motion. It will be converted into reciprocating motion. That is single slider crank chain mechanism. Okay, now.
Yes, sir.
You may see this is the crank. When the crank rotates, the connecting rod is connected to the piston rod by rosette. So when this connecting rod moves, the piston inside the cylinder will be reciprocating. Okay, so whatever is the function of this mechanism is rotary motion into reciprocating motion, conversion of rotary motion into reciprocating. Okay. So next is inversions of single cylinder crank. First is pendulum pump or bull engine. So here you may see two cylinders. Cylinder gets fixed. Cylinders are fixed. So there is a link to which is known as the crank. So when this crank is rotating, the connecting rod connected to A will also move and it will take A. So when this A moves, what happens? The piston inside the cylinder will start oscillating. Okay, no? So whatever rotary motion is there, it is converted into reciprocating. Okay, so this is known as pendulum pump. In this mechanism, the inversion is obtained by fixing the cylinder. In case when the crank 2 rotates, the connecting rod oscillates about the pin pivoted to the link 4 at A and the piston attached to the piston rod reciprocates. So the piston attached to the piston rod will reciprocate. The duplex pump, which is used to supply feed water to the boilers, have 2 pistons attached to link 1. So an example is duplex pump. Okay. So next is oscillating cylinder engine. This oscillating cylinder engine, what happens? The connecting rod gets fixed. Okay. So there is a crank. When this crank is rotating, what happens? The cylinder, it is connected to piston rod and piston rod will take the piston inside the cylinder in the reciprocating direction. Okay. No. So the arrangement of oscillating cylinder engine mechanism is shown. It is used to convert reciprocating motion into rotary motion. Okay. So in this, the connecting rod is fixed. The link 3 corresponds to the connecting rod of the reciprocating steam engine. When the crank rotates, piston attached to the piston rod reciprocates and the cylinder oscillates about the pivoted to the link at A. It's nothing but the concept is clear. When the crank rotates, the piston rod is connected to the cylinder. What happens? The cylinder, the piston inside the cylinder will be reciprocating. So the rotary motion, whatever is there, it is converted to reciprocating motion. Okay, no. So the function of single sided crank is done. What is the function of single sided crank to convert rotary motion into reciprocating motion? Next is rotary internal combustion engine or genome engine. That means this is the type of engine. So there will be a fixed link over here. That means you may see our link. This crank is fixed over here, and through this crank there will be different connecting rods connected to cranks. Okay. So when this is rotating, the cylinders or the piston cylinder will reciprocate inside each cylinder. The piston, whatever is there, it will reciprocate under each cylinder. Okay, now this is known as genome engine. Okay. Next is an important thing. This is known as crank and slotted lever mechanism. So this is usually you can find this in shaping, slotting machine, etc. Shaping machines, slotting machines, or rotary internal combustion engines. So what we are having here is the thing is that you may see this is a ram or the tool will be positioned at ram. This is the point. So you may see over here, this link 3 is known as fixed link. Okay. So in this fixed link AC, at the point A, they have placed a slotted bar. You may see AC. This AP is known as the slotted bar. Slotted bar. Okay. So this AC is fixed. This AP is a slotted bar connected to this one. In this slotted bar, there is a slider over here. Okay. And crank is connected inside. Once again, I will explain. Please listen. If you have any doubt, please listen. So this link AC is fixed. That is this one. From A, you have connected AP. AP is the slotted bar. Okay, slotted bar. Slotted bar. Okay. In that AP, there is a point B over here. Okay. This B is slider and crank is connected to point C. So AC, then CB is the crank. Crank will be passing through this slotted bar. That slotted bar means it can move inside the slotted bar. And this slotted bar, P, from P, there is a connecting rod connecting the ram. Ram is for positioning the tool. Ram is for positioning the tool. Okay. So you may see this B. So I think all the parts are clear. So I think I will explain how it is working. So there is a point B here. This B is not a slider. So when P is at P1, when the P is at P1, that means the slotted bar is at P1. B will be at B1. Okay, now any doubt? This P is at P1, B will be at B. Okay. From here, it starts moving so that the tool will be moving to its front. Okay. So it will move from B to B1 to B2. It will move from B1 to B2. So what happens? The RAM will move from R1 to R2. This is known as cutting stroke. Cutting stroke. So we will be positioning the workpiece over here. It will cut the workpiece. Okay. So it will be moving from B1 to B2. So you may say this is a large circle. Okay. So the time for moving from R1 to R2 will be large because the circle is large, the time will be more. Then it will return from B2 to B1. You may see that's a small circle. So return time is low. So that is why it is known as quick return motion mechanism. So for taking the cut, it will take a large circle. So moving from R1 to R2, it will take time. So that is known as forward stroke or cutting stroke. When it is coming back, it is known as return stroke. But you can see that forward stroke, it takes a large circle. Return stroke, it takes a small circle. So for forward stroke, the time will be more. Return stroke, it will take only very less time. So this is why it is known as crank and slotted lever quick return mechanism. Okay. I think the concept is clear now. So it will be cutting only during the forward stroke. There will not be any cut in the workpiece during the return stroke. The cutting will be happening only during the forward stroke. Okay. So the ram, when it moves from R1 to R2, the position is from B1 to B2. The crank or the slider inside the slotted bar will move from B1 to B2. It is a large circle when compared to the return stroke. So that is why return time is very less. So that is why it is known as quick return motion mechanism. Okay, now the concept is clear now. Next is Whitworth quick return mechanism. This is also another quick return motion mechanism. Here you may see this link CD is fixed. Okay, so there is a slotted bar in which CA is the crank. Okay, then from DP, is connected. From P, the connecting rod is connected to RAM. Okay. So this is the another mechanism which is known as switchware quick return mechanism. So when I am saying this mechanism, you may understand it. If you see the video also, you have a clear idea what I am saying. Okay. You can just search these videos in YouTube. You can find all these mechanisms. Okay. So when you see this video and the concept or the note you see here, you will understand what I am saying. Okay. I think the concept of crank and slaughterware mechanism is clear. This is known as switchware quick return mechanism. So here, at P1, you may see when the P is at P1, what happens to A? This slaughter lever will also turn. It will come over A1. Okay, no? Any doubt? When this P is here P1, this A will be here at okay, it's heavy rain in Kerala. Okay, that's why there is some network issues in between. So I will explain this once again. So you may see when this, so you may see DC is the fixed link, CA is the crank, DP is the position of P. Okay, PR is the connecting rod which is connected to RAM. Okay, so this is with where quick return mechanism we can see the corresponding to the connecting rod of the reciprocal driving C. Okay, so this is no, this is inversion. You may see. This mechanism is mostly used in shaping and sorting machine. In this mechanism, link CD is the turning pair is fixed as shown in the figure. The link 2 corresponding to the crank in the reciprocating engine. Driving crank CA rotates at uniform angular speed. The slider attached to the crank A slides along the slotted bar PA. This is known as slotted bar PA. This is the slotted bar PA, which oscillates in a pivoted point T. There is a point, oscillation point T. The connecting rod PR carries the ram at R to which cutting tool is fixed. The motion of the tool is constrained along line RD and along the passing through D and perpendicular to CD. This is the concept. So when I am saying like this, it will get confused. So I will explain it. Very simple. You may see this CD is fixed. CA is the crank which is connected to a point in slide. Okay. So this P is the point on, PA is the point on slotted bar. And from P, the RAM is connected. Okay. So when this CA is moving, so we consider CA is in the leftmost side. So A1. So this A will be A1. So P will be here, P1. Okay, no? So when this is rotating, what happens? This will be the position of A1 and this will be the position of P1. Okay. So it will be start moving from A1 to A2. What happens? The RAM will move from R1 to R2. So it will be RAM will be moving from, so RAM was in the, when P is at P1, the RAM is in the left extreme position. When A1 starts moving to A2, what happens? The RAM will start moving in the forward direction or cutting stroke will happen. Or cutting stroke happens. Okay. So A1 to A2 represents the cutting stroke. So this is a large circle. So cutting stroke will take long time. Okay. So when this, after when it this A2, P will be at P2. Okay, no? When this reaches A2, P will be at P2. Okay. So when it comes from A2 to A1, you may see it is a small circle. Okay. So again, when it comes from A2 to A1, it forms a small circle. So A1 to A2, you may see the circle is large, and A2 to A1, it is a smaller circle. So the return position is return motion is small. Okay, no, this is large. So that is why it is known Whitworth quick return mechanism. These both mechanisms are used in slotted and shaping machines. So one is crank and slotted lever mechanism, and another one is Whitworth quick return mechanism. Okay, no? I think the concept is clear, no? Should I explain this once again?
No, sir. Okay.
Thing is that if we place a workpiece over here, when this slotted bar moves from A1 to A2, what happens? P1 will move from P1 to P2. So RAM will move from R1 to R2. And when we place a workpiece over here, it will cut the workpiece. Okay, so this is the cutting stroke. So after that, when it changes from P2 to P1, you may see the circle trace during the forward stroke is A1 to A2, which is a large circle. So the time will be more. When it comes from A2 to A1, the circle trace is small. Okay, small circle is traced. So it becomes a return stroke, and the time for return stroke is small. Okay, so it forms a Whitworth quick return mechanism. Okay, the concept is clear now.
Yes, sir. Okay.
Yes, clear, clear.
So I think the time is over. Okay, so we shall continue in the next class. Okay, so I will share the PPT with you. Okay.
Okay, sir.
Okay, thank you.
Okay.